I'll begin with a word of prayer. So. Dear Heavenly Father, we thank you for this day. Again, I thank you for these students and for this class. Just pray that you bless this time, help us to use our time wisely and to glorify you in what we do. We thank you for your creation. We thank you for math, and we thank you for us being able to enjoy it. Help us to just learn what we need to from this time, and again, to glorify you in the process, Lord. In your name I pray. Amen. Okay, so you guys are done top hatting. Hooray. Close this thing down here. So just a couple of bookkeeping things. Number one, I had in my labs, like I had the email set to my previous institution, so I wasn't getting any. I feel like you emailed me something within my labs, like ask your instructor or something, whatever it's called. I didn't get those, but I changed my email in the my lab, so now that I should. All right, so if you contact me that way, I should get that email. But if I don't respond within like a day, odds are good that it's not getting to me. So you should just email me, right? jcook4 at liberty.edu. So if in doubt, email me again. Say, hey, did you get the email I sent through the thing or whatever? That's fine. All right. So that's the one thing. And then the other thing is, some of you are asking questions about like grades in Canvas versus in my labs. As a generic point of order, grades in my labs are real. Those are real grades. Grades in Canvas may or may not be real in terms of they may or may not have actually transferred. So if you may have a 0 in Canvas, but you have 30 points in my labs, you have 30 points. It's just a matter of time before the grades sync and come over to Canvas, all right? So just, I think I have fixed all those issues. We have, I've turned the grade sync on wherever I could find it. I think it should sync. I think it will not sync until the due date, I think is how they have it set up. So like you'll be getting points. You look in my labs, in the grade book in my labs, it'll tell you how many points you have, how many green checks you got, right? Once you've got all the green checks, then you're done, right? And then at some point, the due date will pass, and then that will propagate over to Canvas. So do not despair if you have 30 in my labs and 0 in Canvas. Unless, of course, we're like weeks and weeks from now, and for some reason it hasn't gone through, right? Like in the future, we should worry about it. But at the moment, it's just the ebb and flow of syncing between my labs and Canvas. Now, if you're worried, just email me and I'll look at it again. But I think everybody's fine. Any questions about anything before I get into the math here? All right. So let's talk about inequalities today. So we're talking about inequalities. And interval notation. And of course, we're also going to be talking about number lines. So let me just kind of give us a list of examples, sort of generic examples, if you will. Let's see here. So might have a number line. So I'm going to draw a number line. That's probably enough. We'll find out. All right. And so I'm going to make the interval I'm talking about red. All right. So we could go with something like this. From A to B. That's what it would look like on the number line. The interval that corresponds to that, if this is a point x here, we could say x is an element of A to B. All right. This right here means element of. Element of. All right. And to be explicit, what this is this is x such that A less than x less than B. All right. One possibility. Another possibility could be like this, square bracket from A to B, right? So in this case, if I have x in here, x would be an element of what? A is included to b. So this would be x such that a is less than or equal to x is less than b. What else could we do? Well, we could include both endpoints, right? Like that. Then if that was the case, if x was in here, we would say x is an element of a to b. And this would be x such that a is less than or equal to x, less than or equal to b. What else could we do? Ideas? A to infinity. All right. You want to include a or exclude it? Include it. All right. So like a to infinity would look something like this on the number line, right? So that would be x in here. X would be an element of a included to infinity. That is the set x such that x is greater than or equal to a. You could also do, let's say, a excluded to minus infinity, right? Like that. And that would mean x is an element minus infinity to a not included, right? And that is the set x such that x is less than a. Few more flavor options here, right? You could do what? Oh yeah, if it's just the whole real, fair enough. If it's the whole deal, then we say x is an element of minus infinity to infinity. I almost forgot that. And that is what we also denote by this. It's the real numbers, the whole real line. Basically, the only condition we put on x here is that x is a real number. Right? I think there's other cases, right? But does this suffice? I think this is enough for us to write down. We'll deal with the other cases as we hit them in examples. Does that sound good? I hope it does. Because that's all I'm going to write. So here, let me stop there. Past this point, my handwriting gets really messy. So let's look at some examples. Actually, before I do that, I should just mention a couple properties of absolute properties. Of less than or equal to and greater than or equal to, right? So let's just go over some basic properties we need to know, right, to work with these. Oops. All right, first of all, and this is kind of silly, but you know, a is less than or equal to b is interchangeable with what? B is greater than or equal to a, right? So you can always flip less than or equal to for greater than or equal to, right? This is something we can do. Another thing we can do is that if we have, let's say, a less than or equal to b, then that implies that a plus c is less than or equal to b plus c, right? So we can add to both sides of an inequality, right? We can do that. We could also subtract, right? We could subtract, right? Right. Now, multiplication, on the other hand, multiplication's a little tricky, right? We gotta be careful with multiplication. So here's the deal. If c is greater than 0, then a less than or equal to b implies that ca is less than or equal to cb. That is true. However, right, if c is less than 0, then if we start with a less than or equal to b and we multiply by c, it flips the inequality. Right? So when we multiply by a negative number, we had to be careful. That will flip our inequalities, right? So those are the big ones, all right? So let's work with these. And so what's the basic strategy for solving an inequality? Strategy. Seems wrong. Roadmap, how about that? There we go. Basically, it's just this. Isolate x, okay? You want to isolate x, all right? If we can do that, that will probably show us what the solution should be, right? So you want to isolate x, and then you want to write answer using number line and or interval notation as appropriate. What's appropriate? Well, that depends on the question, right? Some questions ask you for a number line, other questions ask you for interval notation. So here's example 1. Let's suppose we're going to solve 3x minus 8 greater than 2. So what do you want to do? Add 8 to both sides. I like it. So one thing at a time. Let's see here. So we got 3x greater than 10. Now I heard divide by 3. I like it. Divide by 3. We get 3x over 3 is greater than 10 over 3, right? AKA x is greater than 10/3. So that, in some sense, that's one way to write the solution, right? We could say solution set. It's x such that x is, well, we could say 10/3 is less than x, right? We could write the solution like that. Fine. If we drew a number line, right? And let me put some points of reference on here. I don't know, 4, 3, 2, et cetera, right? Where's 10/3? It's 3 1/3, right? So it's like 3.33333. So like pictorially, this guy looks something like x is bigger than 10/3, right? So it's like this. X is over here somewhere, right? So that's a number line picture of the solution. What's the interval? This is equal to 10/3 to positive infinity. There you go. So 3 different, well, arguably 4 different ways to write the answer, right? Set builder notation. This right here is set builder notation. This notation right here, this vertical bar, is supposed to be read such that. So the way this notation works is you put the objects that are in the set here, right? And then you put the condition on those objects to the right of the such that bar. So that's one way we can describe sets. Let's see here. So let me go ahead and erase the properties, because I think you guys already know this, right? Well, knowing them and implying them are two different things, aren't they? Let's try to apply it to a different problem here. So what if we're faced with something like x plus 7 less than 3 minus, oh, I don't know, 2x less than or equal to 8 plus x. Suppose you wanted to solve this inequality. So what would you recommend we do here? Any suggestions? Combine all the x terms. Like, how about this? We subtract x across it, right? Like, if I subtract x, that gives us 7 less than 3 minus 3x less than or equal to 8. We want to isolate the x, right? So then I think we should subtract 3, right? We subtract 3 across the inequality. This gives us 4 less than minus 3x less than or equal to 5. Now what? Divide by negative 3. Right. You can do it, but what do we have to do when we do that? Yeah, we have to flip the less thans to greater thans, right? So I get minus 4 over 3 greater than x greater than or equal to minus 5 over 3. And as a point of just bookkeeping, I prefer to write it the opposite way. All right, so this is the same, right, as what I'm about to write in red, namely minus 5/3 less than or equal to x less than minus 4/3. So what does the solution look like on the number line? If we got, say, minus 1 here, minus 2 here, minus 3 here, our solution's going what? From like minus 1.333 and so forth and so on to what? Minus 1.66666, right? So, sorry, not a good choice of scale, but something like this one. This one's not included, right? And then this one's included. So it'd be something like that, right? So what's the solution here in interval notation? We do, oh, my bad. We want to include the minus 5/3, and we want to exclude the minus 4/3. But there you go. That's the solution right there in interval notation. Should we do another? I think we should do more, right? All right. Here's an ugly looking one. I'll do this one here. Example 3. 1/2 x plus 1/3 x minus 1/5 x plus 6 less than or equal to 1/10. All right, we want to find the solution in interval notation. So what do you want to do here? Do you guys enjoy adding fractions? I don't. How to make the fractions go away? What can we do? We can multiply the inequality by the least common multiple of the denominators you see at play, right? So you got a half, a third, a fifth. I think if we could multiply by, you could multiply by 60. That would fix it, but that's probably a little bit too greedy. I think we could get by multiplying by, what, 30? I think 30 would make all those fractions turn to whole numbers, right? Multiply by 30. And so we get, what's 30 over 2? It's 15. 30 over 3, 10. 30 over 5, 6. What's 30 over 10? 3, right? So multiplying by 30, 30 over 2 is 15, 30 over 3 is 10, 30 over 5 is 6, and of course 30 over 10 is 3. Now what? Let's multiply this out, right? What we got? We got 25x, right? Minus 6x minus 36 less than or equal to 3. I think we should do what? We should add 36 to both sides, right? Do you think, does it make sense? Add 36, I think. What's 25 minus 6? It's 25 minus 6, I think it's 19, right? 19x less than or equal to, I believe, 39. One more thing to do, right? Divide by 19. Divide by 19, what do we get? X less than or equal to 39 over 19. So what's my solution? In interval notation, what do we want? We want minus infinity all the way to 39 over 19, included or excluded? What do you guys think? Included, right? Because it's less than or equal to. So there you go. This is the solution set to that somewhat ugly looking inequality. Now, if you're unclear about how to get from here to here, what should you do? If you didn't see that, how do you get from here to here? What's a way you can do it? You can draw a number line. You can put 39 over 19, and you can ask yourself, where does x go? X goes to the left, right? Which gives you this deal, right? Which is minus infinity to 39 over 19. You don't have to write that down, but if you're not clear on how to get from the from the inequality to the interval, that's a good help. Let's do another. Go for it. Let's see here. Oh no, my pages are out of order. There was one on the first page I wanted to get. Oh, here it is. Example 4. Suppose you want to solve 5x plus 7 divided by minus 2 is less than or equal to 3x plus 5. Again, we want to write our answer using interval notation. All right? So what do you want to do? Again, we don't like fractions, right? So if we multiply this by minus 2, life gets easier, right? Now we got to be careful. When we multiply by minus 2, what must we mind? be careful to flip less than or equal to greater than or equal to, right? So we get minus 5x, my bad, 5x plus 7 greater than or equal to minus 2 times 3x plus 5. So of course the minus 2 over minus 2 cancels on the left-hand side, right? And we can distribute that, right? So we've got ourselves a 5x plus 7 greater than or equal to, let's see here, minus 6x minus 10. So what I would advise doing here is adding 6x to both sides. All right? If I add 6x to both sides, what happens? We get 11x plus 7 greater than or equal to minus 10, right? Now what should I do? Subtract 7 from both sides. Now some of you might be like, couldn't you have just done that in the last step rather than making so many steps? Well, yeah, sure. But I'm trying to make a few more steps for the people who are more lost in here. So that's 11x greater than or equal to minus 10 minus 7 is minus 17. Now divide by 11. Do we have to flip? No, we're dividing by positive number, so that doesn't flip the inequality. Right? And if you want, you can make a number line picture here, right? What's the number line picture for this? X is bigger than minus 17 or 11, right? That means x is like over here somewhere, right? So the picture is something like this. What's the answer? In interval notation, we have minus 17 over 11, comma, infinity. This is the solution in interval notation. You like these? You like these more than factoring? Well, on that note, this is how we can solve linear inequalities. Linear inequalities, so how do you solve a linear inequality? A linear inequality you solve by isolating x. Pretty much, that's it, all right? So examples 1 through 4 illustrate what are called linear inequalities. And so I would say for linear inequalities, yeah, we can just use the basic properties of inequalities and solve for x, right? The main thing you have to learn here, or remember, right, shake the cobwebs loose, whatever the case might be, is this pesky interval notation, right? And these number line pictures, right? I should mention, there are different notational strategies in different places. So like if you look at my old solutions, you may find this used instead. So this is like another notation for this. All right? Or for the closed interval, like this, instead of using this. Right? So your text uses the brackets and the open intervals. Other books use dots or open or closed dots. I like the open or closed dots because we also use that open or closed dot notation when we're talking about graphing. So that reinforces that idea. If you use the open closed dot notation in here for your solutions, I won't take off points. But I don't even know how you do it in the MyLabs because they have multiple choice with the pictures, but whatever. The one notation I will not allow, and I told the other section this too, I feel like I should tell you guys too. Any of you have a French background? French mathematics? So some of the French, they write it this way. Not a joke. Like, this is a serious notation. I have books full of this. And I'm sorry if you're of a French mind, but this I forbid. So I'm pretty open-minded, but the French notation I must rule out. You guys have any experience with the French? No one has any experience with the other section also don't know the French. So I'm afraid the cultures, they can never learn from each other. We don't know French. It's a sad. Oh well. Maybe if we're lucky, some French person. I'm not trying to objectify them as a French. A French person will watch the YouTube video and then we'll get their perspective. But anyway. All right, I digress. So what's up next? So you're just celebrating the lack of factoring in this lecture. So let me ruin it for you. So nonlinear inequalities. Our next topic. We really do need to use factoring and what I call the number line technique. So we're going to we'll use factoring and number line technique to solve. All right. So here's the basic idea. Step number 1, you find all numbers where either the expression is 0 or undefined. All right. Step number 1, find all numbers where the expression is either 0 or undefined. Step number 2, plot numbers from 1, and let's call these numbers algebraic critical numbers, just to give them a name so we can talk about it. Let's find the algebraic critical numbers. Hey, we're only talking about algebraic critical numbers in here, so if you just want to call them critical numbers, feel free. Critical numbers. So you plot these critical numbers from 1 on number line. All right, and step 3 is you test point in each case to determine plus or minus. And we can use the even odd trick to cut down our work. All right, that's the game plan. That's the roadmap. That's what we're going to do. Let me bring this to life with examples, okay? So I'll start with a relatively simple example, although it will involve that nasty factoring. So like x squared minus 3x plus 2 greater than 0. All right, so the expression here is x squared minus 3x plus 2. You can factor that, right? This is x minus 1 times x minus 2. So critical numbers are 1 and 2. Those are the places where the expression is 0. Are there any places where it's undefined? No, I mean, it's x squared plus 3 minus 3x plus 2. Its domain is the whole reals. So there's no undefined points here. Now we draw our number line, like so. You put 1, you put 2. That's the order they go on the number line, right? All right. There, I'm on step number 2. Plotted my number line. Step number 3, I test a point in each case. So, you know, how about here? I could test, over here I could test 0, right? 0's here. Plug 0 into this, what do you get? Just, no. Oh, this. Yeah, you're answering literally what I'm pointing at. Yeah, 0 squared is 0. But we get 0 squared minus 3 times 0 plus 2. We just get 2, right? Plugging 0 into the expression gives us 2, which is positive. So I just put pluses. All right, what's between 1 and 2? We could pick like 1.5 as a test point. Yeah? So 1.5, if I plug it in, it's better to use the factored form for 1.5. 1.5 minus 1, 0.5. 1.5 minus 2, minus 0.5. So we got plus times minus. Plus minus is minus, right? Minus is up in here. And over here, like 3, for example, you could use as a test point. 3. So plug 3 in. 3 minus 1, 2. 3 minus 2, 1. So we've got plus times plus, which is plus again, right? So that gives us pluses. All right. Oh, I forgot step 4. Write down answer. Because once you've done this much, you can literally read the answer off the number line. I'm trying to solve that's greater than 0, right? So the solution, set minus infinity to 1, not included, union 2 to infinity. There it is. This thing in the middle is union. You guys remember union? Maybe, maybe not. I will remind you. A union B is x such that x is an element of A, or x is an element of B. This is when we take two sets and combine them. You're in the union if you're in either one or the other or both. So it's the union of minus infinity to 1 and 2 to infinity. Why did I put those? Because that's where we got the pluses, right? We're solving greater than. Like example 6 rather. Example 6. See, if I was solving the related x squared minus 3x plus 2 less than or equal to 0, by the same work I just did, exactly the same problem, but less than or equal to, just look at the number line, we go from 1 to 2. So solution, 1 to 2. Now this time, do I include or exclude 1 and 2? What happens at 1 and 2 for this expression? If you plug in 1 or 2 into x squared minus 3x plus 2, you get what? No, if we plug 1 in, like, just look at right here. So what happens if we plug 1 or 2 into this expression? It what?
Wait, cancels out.
It cancels out, right? You get 0 either in this one, if you plug in 1, right? Or in this one, if we plug in 2. Either case, we either get 0 times something or something times 0. 0, right? 1 and 2 give you 0. Are we looking for 0? Less than or equal to 0, right? So logically, we have to include 1 and 2 here. In contrast, up here, I had strictly greater than. See, the equals wasn't included? That's why I had these parentheses here. I didn't want to include the 1 and 2 there. All right, so here's a trick. The even-odd trick. Even-odd trick, what's that mean? It means that odd powers flip sign at critical numbers. Even powers don't flip. Don't flip signs. What am I talking about? Here, this is x minus 1 to the first power. This is x minus 2 to the first power. As we go across the critical number 1, we flip from plus to minus. And then here we flip from minus to plus. When we have odd powers, we're going to flip signs as we go across the critical numbers. If you have even powers, this doesn't happen. So like example 7. So if I had like x minus 2 to the fourth power times x minus 5 to the third power divided by x squared plus 1 times x minus, oh, I don't know, how about plus 3 to the 7th power. I want to solve that greater than 0. Now I did the hard part. I already factored it. All right? I already factored it. What are the critical numbers here? Oh, did you move it? Oh, thanks. So critical numbers. Look at it. You got 2. You got 5. You got minus 3. How about x squared plus 1? Is that ever 0? No. In fact, that is greater than or equal to 1. That thing is always positive. It's essentially irrelevant to this question. You could get rid of it. It would be the same problem. This x squared plus 1 factor. So our critical numbers are 2, 5, and minus 3. So I make my number line like so. Put my minus 3 here. Now you got to be careful about which order you put the numbers. If you put the numbers in the wrong order, that will mess you up. I've done that. If you do that and you don't realize you've done that, it gets really, really confusing until you finally see it. But so the numbers must be put in order, all right? Now, here's the trick. You test one point. What's an easy point to test? How about, I always test 0. 0 is easy to plug into expression like this here. So 0 is here, right? This case is where 0 is between minus 3 and 2, right? That's where we change from minus to plus. Plug in 0 up here, what you get? I'll write it out. We get minus 2 to the fourth power minus 5 to the third power divided by 0 plus 1, right? And then 0 plus 3 to the 7th power, which, just keep track of the signs, is plus times minus divided by plus, right? Which is minus, right? That's a negative number. I don't really care what the number is, it's negative. Okay? Now, if I use the even-odd trick to do the rest, all right, let's look at it. 2. 2 corresponds to what? It corresponds to x minus 2 to the fourth power, right? That's an even power. 4 is an even power. That means that as you go from here to there, you're not going to change the sign of the expression. If you think about it logically, the other things like x minus 5 and x plus 3, they don't change as you go across 2 in terms of their polarity, in terms of plus or minus, right? So we just stay minus. All right? In contrast, minus 3, right? It corresponds to x plus 3 here. That's a 7th power. That means we flip the sign. So I go from minus to plus as we cross minus 3. How about 5? 5 is an odd power, right? Yeah? See, x minus 5 to the third power. So again, we do what? Flip it, right? So we go from minus to plus over here. most often, the power that you'll encounter is just like my example 5, which was just power 1, right? Like these are power 1, you know? But that is odd. Yeah? All right. Now that you get all this, so this is it. Now we can write down the answer. What's the answer? The solution set is equal to what? Minus infinity to minus 3, right? And then union 5 to infinity. And I got to be careful here because I'm going to trick myself. If I'm not careful, I'm going to miss something. So you guys, do I include or exclude minus 3? And why? What's going on at minus 3? See the expression? Minus 3 puts a 0 in the denominator. This cannot be permitted, right? So we have to exclude that. That's not something that's well defined. We don't have a positive number if we have division by 0. We just have something undefined. So we must exclude the minus 3. On the other hand, 5, what happens at 5? You get 0 in the numerator. That's okay. We can have 0 in the numerator of a fraction. That just makes the fraction 0. So that we include the 5. All right. Now, if you were to write this down as the answer to this problem on the test, I would give you 90% of the credit. But technically, we're missing one thing. Oh, wait a minute. No, we're not. Actually, as it stands, great. That's the answer. Except it's not. I'm an idiot. Because we didn't, this wasn't, it was greater than. I was giving this was, I'm assuming what? I'm assuming what when I write that? Greater than or equal to. My bad. Sorry. I was answering greater than or equal to, but I have written greater than. Yeah, there's a difference. So, yeah?
If it's greater than that, 5 would be a hard number to solve.
Yeah, let me put the answer without the 1. So this, as it stands, would be the answer for greater than. Greater than or equal to, I'll put below it. Minus infinity to minus 3, unioned with 5 included to infinity. But there's something else. How else can we get 0? Two, right? 2 is an answer. See, because if we plug in 2, we get 0. So you got to be careful in this kind of problem. You might also have to take the union of just the set just containing 2. So this is the set just containing 2. So-called singleton. Technically, I guess that's also an interval, but people can debate about that, I suppose. Yeah. Now, can you solve these problems using the techniques we use to solve problems 1 through 4? You can, but they involve case-wise logic. Like this problem, you would have to break into 1, 2, 3, 4 separate cases. And subject to the terms and conditions of each case, you could work out the inequality and solve it. Right? But it's so much simpler to identify the critical numbers, draw the number line, and sort through it like this with a diagram. Right? Did we need the diagram for examples 1 through 4? We did not, right? Those you can just solve, isolate for x. But when you have a nonlinear one, you need to use factoring and the number line idea, right? So we'll do more of these, all right? But next time we'll also talk about absolute value, how to solve it, and how to work with inequalities using absolute value. So please pay close attention to the next lecture. That absolute value inequality is something that always stumps a lot of students on test 1. So I'm just warning you.